Hey, how's it going? I thought I'd do something a little different, something I've been meaning to do in a while, and it's smart contract programming. Sometimes I get questions on where to start, how to make sense of all the tools in what they call the Web3 ecosystem. So I thought I'll put together what I consider a get started guide using examples directly from the Solidity official documentation site. I have that open right now on my screen. If you take a look at this example here, there is the Introduction to Smart Contracts. This is directly on docs.soliditylang.org, a simple smart contract. There's a storage example in here, so that's gonna be the one we'll be using. We're gonna try and implement over the course of this, I don't know how long this video is gonna be, but over the course of this sort of series, we're gonna just go and implement all of this, but on a local blockchain. Just to give you a quick introduction to the language we'll be working with, Solidity is the programming language that smart contract engineers use to write and implement smart contracts, code that runs on the Ethereum blockchain. And examples of smart contracts applications are in areas such as crowdfunding, such as auctions, votings, insurance, obviously non-exhaustive, the list goes on. And the Ethereum virtual machine, or the EVM, is the runtime environment for smart contracts in Ethereum, and that's all about you need to know. Now, to follow along this video, we'll go ahead and implement a simple smart contract straight from that documentation, but it needs to be run somewhere. It needs to be run on the blockchain. So for that, we're going to be using Ganache. So let me show you how Ganache looks like. This is Ganache, right? It allows you to quickly fire up a personal Ethereum blockchain, which you can use to run tasks, execute commands, inspect state while controlling how the chain operates. So there's really a lot of UI. You can see here while you interact with your smart contract. You see accounts, blocks, transactions, contract events, and you can see the log. So when you deploy a smart contract, how does it look like? So all of this is right in here. Okay, so to download Ganache, let me switch over again, and in a browser, all you need to do is to just search up Ganache app download, and just click on the first one here. And click on, it's detected that I'm on Linux system, so it recommends that, but you should probably see Mac or Windows depending on what OS you're on. And probably what you need is a local working version of Python as well, and I'm using Visual Studio Code, so you probably want to go ahead and install that as well. Now, why Python? Because most of my viewers are probably going to be the most familiar with Python, so I'm going to do all of this in Python. But if you want to see this implemented with JavaScript, leave a comment and let me know. All right, so I hope you're excited. Let's get started. Right now, the first step is to install Brownie. Right, there are many ways to install Brownie. There is the you can do it with pipx, you can do it with pip, but it's written in Python, so you will need to have Python 3, and you can go ahead and use the instructions here. You can say pip install pipx if you don't have pipx, and you can use pip pipx install fbrownie. So how that would look like if I show you my code right now. Right here, so in my code terminal, you could go ahead and just pipx install fbrownie. That's all you need to do, right? Now the second way, if you don't want to use pipx, let's go back to the browser. If you don't want to use pipx, there is also pip. So just do a pip install fbrownie. Now ideally you want to install this in a virtual environment, so you don't want to put this in the global space and pollute your global. So scope it up properly, put them in a virtual environment. If you don't know how to do that, there are other videos. I have other videos to talk about that, but go ahead and do the installation. And just to make sure that you've done all of this right, you will see a complete, and you can type Brownie to verify that it works, right? So I'm gonna go back to my terminal, and if I do a Brownie, it's gonna show me this. You can also do a Brownie -- version, and you will see 1.18.1. It's up to you. Just try it. Go ahead and let me just actually have this quick more space up here. You just want to make sure that you have Brownie installed. So if you need to take a second, pause the video, go ahead, make sure that it's installed, and then we'll come back and we'll get started with that. Once you've installed Brownie, then you want to have your Visual Studio Code or your favorite IDE open up, and first thing is to make sure that you learn the shortcuts. I'm going to use the terminal right in here, built in here. So you can use control backtick to just toggle it on and off. I'm just going to say control backtick. It's going to come up. find a place where you want to put all of these projects in. It can be a desktop, it can be a Dropbox folder, it can be documents. It's up to you, right? I'm just gonna put them somewhere in this folder that I just created. So right now there's nothing in there. If I put ls list, it has nothing. There's completely, it's a blank open folder. It's just a folder that I just opened up. There's nothing in here. So first thing we're gonna do is to just go ahead and scaffold out the project. And for this, Brownie is really good at that. And the way we're gonna do that is we're just gonna call Brownie, and we're gonna say Brownie init. Now I want to just make sure that I'm in the right version of my virtual environment, so I'm gonna just make sure of that. And if I search for that, I'm in my virtual environment. I created one called Web3, so I'm in that. You probably don't have to do that right now, as long as you know that you're in the right virtual environment. Go ahead and just do a quick confirmation if you want to, but for now I'm in there. So I'm gonna just say Brownie, and I'm gonna say init. Brownie init is gonna just initialize a Brownie project for you, so it's gonna do all of this. And really quickly, you see that it's created all of the files here, all of the folders in here. And if I drag it up a little bit and I show you all of the folders, yep. So now I have, before Brownie init, this is a blank empty directory. I say Brownie init, and it goes ahead and create all of these folders for us, right? So there's a build folder. This is when we compile our contracts. It builds it, and here is where it's going to be stored, right? So you find the contracts, and every time we deploy our smart contract, it's going to be in the deployment. And we haven't really talked about the concept of interfaces, but this is where it's going to be stored as well. Contracts is where we're going to write our Solidity code, and this is where we're going to start doing our first step. So let's go ahead in here. You can either use the mouse and just say right click new file, or you can just go ahead and create the file right from the terminal. So you can say touch, and we're gonna say contracts and simple storage. So simple storage.sol. SOL stands for Solidity. So this is also a good time to actually talk about, if I create that, you see that it just created a file here. This is a good time to talk about a Python, actually a Solidity extension that you can use. So I want you to go click into extension, Control-Shift-X, and from here search for Solidity, and you should be able to find this, the Ethereum Solidity language for Visual Studio Code. So all you need to do is to go ahead and install that, okay? And once you've done that, come back to the folder, right? And scripts is where we're gonna write our Python script. Okay, we haven't really getting that yet, so make sure that you've, up to this point, it shouldn't be too much of a trouble, right? Go ahead, install extensions, go to contracts, create something called simple storage.xol. You can right click new file, you can go ahead and just say touch. That's up to you. But I know that I'm also going to be writing Python code, so I know that I will have a script that that deploys this to a local Ganache. So I'm going to just go ahead and also create that file. So I'm going to just say touch and put that in the scripts folder. So scripts folder is where I put all my Python code, whether it's to create a new user account, to deploy a smart contract, to create a smart contract, all of that. I'm going to store them in scripts. So I'm going to call it deploy.py. And now if I print up LSD, you should see there is now, okay, so let's do a tree. You should see now that there's in contracts there's simple storage, and in scripts there's deploy.py. So this is all good. This is a good start, right? So go ahead, pause the video if you need to. Make sure that you have this files hierarchy that you see on my screen. Okay, once you're ready, click into simple storage.sol, that's Solidity, and we're gonna start writing our code in here. All right, so for a smart contract, the first line, typically we want to have our license identifier. So we want to tell everyone what license apply to this smart contract. So to do that, the convention is to, let me turn off this one. Let's disable that. Okay, right, to get started, let's go ahead and just say spdx license identifier, and you can have an MIT license, you can have a GPL. I'm gonna say stick to GPL 3.0, but it's up to you what kind of license you want. There's a documentation that I'll link you where you can go and read up about what is the philosophy of this, or, what are the choices here. But really what this is telling everyone who's going to look at our code and say, hey, this is the license that apply, all right, for a smart contract. And then the next thing you want to do is to tell your compiler what version of Solidity do you want this to compile on. So I'm going to say pragma and Solidity, every time you see the word pragma, it actually kind of it's telling the compiler what to do, right? It's giving instructions to the compiler. So here we're saying that we want to support anything that is, let's say, 0.4 version and above. And right now, as of today, which is March, midway March, 14th of March, the latest version of Solidity is 0.8.12, I think 12. So you can actually go all the way up to 12, but I'm gonna just go up to 0.9.0. So this is what this is saying, is that as long as the version of your Solidity is above 0.4.22, below 0.9.0, then it's fine, right? So anytime, let's say in the future version of Solidity, if it goes above 0.9, they are probably most likely they're going to introduce some breaking changes, and you're saying that, well, that's probably not going to work, right? So this is the instructions to the compiler. And here is where we actually start to write our contract code. So we go ahead and just say contract simple storage. In a way, I kind of like to keep it to a convention. If I name this simple storage, I want this to be simple storage. So capital S, capital S. So this is simple storage.sol, this contract simple storage. Okay, and you can save that right now. And if you look at the build folder, there's still nothing in the contracts. But if you go ahead and compile this, now there will be something in there. Right now, it's not very interesting. There's nothing in there. So let's go ahead and create a variable. Think of simple storage as, you know, think of this as this is the way you define a contract. And within the contract, you can have methods, meaning the functions, the methods, and you can have the attributes, right, the states that relates to the smart contract. So in here, we're just gonna have a variable, sort of a state variable called stored data, and this is gonna be a unsigned integer. So 256, and we're gonna say stored data. If you're used to something like TypeScript and stuff, this looks very familiar already. You might even confuse this and say, hey, does it? But it's not, it's its own language, okay? But this is the way you define a variable. You create a variable called stored data, and you're saying that it should take, it should be of the type unsigned integer 256. Okay, then let's just do a quick compile. So go back to your terminal. Again, the shortcut to do that is to use control backtick. Control backtick brings you back in the terminal. If you want to go back up, you say control 1, and control 1 brings you back in the IDE. So now you type something, you want to go back to the terminal, you say control backtick, and you type something in the terminal. So control 1 brings it back in here, right? So let's go into terminal, and right now, just go ahead and do a quick compile. So Brownie compile, run that. It says project has been compiled using what version? 0.8.12. That's my version. Okay, that's the latest version. Now, if you want to change this, if there is a reason for you to want to change this, you can go ahead and just say right click. Make sure that you install the extension that I just talked about, the Ethereum Solidity extension. You can right click and you can change your compiler. Okay, you can say change compiler version and change it to a different version. But for me, I'm going to use the latest one, which is 0.8.12. It says project has been compiled, and it's safe here. And once it's safe, you should be able to now click on build contracts, and you will find simple storage.json. And this is the ABI. We haven't talked about that yet, but this is really helpful, right? Go ahead and create the simple storage.json for us. This is the compiled contract. So again, the command is Brownie compile. Okay, so Brownie compile is going to take a look in your contracts, and it's going to find the contracts that you just written, and it's just going to compile them and put them into the build folder, sorry, in the build contracts folder. And if you deploy that, it's going to be in the deployments folder. So for now, this is all you need to do. You have one state variable. Let's go ahead and provide some methods for us to change the variable here, right? So let's create a setter and a getter. So let's go ahead with the stat first. So let's say function set, and we're gonna say unsigned integer. Again, we're gonna have 256, and we're gonna take one parameter in here. So we're gonna say take one argument, and this is gonna be a public function. So a public function allows anyone, this is going to be publicly available. So any other smart contracts apart from, this is our smart contract, but on the blockchain, there'll be other smart contracts, there'll be other people, you know, with their own code, and they will be able to have visibility into this. They're going to be able to call this function, okay? Later on, we will discuss about other ways where you probably don't want a public. You can have a private, you can have, you know, the other modifier on this. But for now, let's make it a public method, so anyone can call it, anyone can see it, And here what we want to do is to change stored data into this new X that we just received. So the way to do that is later, somebody could call a function, like they could call our simple storage, and they could call set, and they could pass in a value of 5, and that 5 should then alter the value of stored data. So this is how it's going to be used. And let's go ahead and say stored data, and that's gonna just be _X. That's it. So that's your setter. Now let's go ahead and also create a getter, and again it's going to be public because we want anyone to be able on the blockchain to be able to just call this method and then retrieve the value. So retrieve the value of what the stored data is. So you can name it retrieve if you want to. I'm just going to keep it short and quick. I'm just going to call it get. Okay, so just going to say get. And does it take any arguments? No, because you just want it to get. There is no need to receive any arguments. So again, it's going to be a public. And because we're not actually changing or modifying the state of this contract, so we can actually just say it's a view function. A view function is saying that we're making a promise that, hey, we're not altering the value of any of this. So public view, what do you want to return from this function? We said returns. Well, this is a unsigned integer 256, so let's return exactly that with unsigned integer 256. So this is the way of saying that, okay, if you call this function, it's going to return something, and the something would be unsigned integer 256, which is this. And so let's write the body of the function now, and it's just going to be simple return stored data. You want to put a semicolon after all of this, like that. So now you can save your contract. Looking sharp, goes into terminal. Go ahead and do a Brownie compile. And project has been compiled. Okay, well done. Now let's go ahead and actually spin up our local blockchain. This is Ganache. When you first install it, and just open it, you should see that this is the main interface. There is the quick start, and it says this is a quick start for one-click blockchain or create a new workspace for advanced setup options. Now we're just gonna go ahead and just say quick start, right? So let's run that. It's gonna take a while, and then when it's done created, it's gonna give you a few things here. So the first thing it's gonna do is it's gonna go ahead and create a set of fake accounts. These are all accounts. These are all the addresses of your blockchain accounts. And each of this is a wallet, and you can take a look at the balance. So each of them is also given 100 Ethereum right now. So all of this, obviously none of this would work on the real Ethereum. This is all completely on your local blockchain, okay? And then there's the blocks, there's the transactions. There is nothing in here, right? No contracts, no transactions. And what we're gonna do now is we're gonna go back to Brownie. So let me close this one out. So this is Brownie, and we're gonna go ahead and actually write something or deploy something. Write this into our allow this to be deployed onto our local Ganache blockchain. So make sure that you still have Ganache running somewhere. But now go back to your Visual Studio Code, and let's go ahead and try to deploy this. Okay, and the way we do that, we can use any method, but I'm gonna just use Python. Okay, and that's the reason you're installing Brownie in the first place, is that you want to be doing most of this in Python. So remember, we created a file called deploy.py. So the way we now interact with that is through this deploy.py, and we created that under scripts. So you can go ahead and click that and create that, or you can use the shorthand. The shorthand is to Control P and just type deploy.py. So that would search up the file, and it would just press enter, and it opens that up. You can also just left click on the tree if you want to, and if you think that this is too troublesome, just hide the bar as well. You can just Control B to hide the sidebar in here. Okay, we're just gonna keep it there. So deploy.py is gonna be fairly simple. All we need to do is to just import from Brownie and import a few things. We need to import our contracts, and we need to deploy that. So let's go ahead and say from Brownie import simple storage. Now remember, I named it simple storage in the contracts, and when it got compiled here, simple storage under contract. So we want to make sure you install, you do that. Okay, I'm gonna have to deactivate that as well. Okay, and then we're gonna say define, create a main function. It needs a main function, by the way. When you call Brownie and you say run the scripts, it needs to find a main function. So let's create a main function because it doesn't exist yet, right? We're just gonna go ahead and say simple storage. let's say simple storage deploy. It needs to decide from where do you want to deploy this. So there needs to be somebody have to deploy this and maybe pay a bit of cost to deploy that, right? So this is where we could make use of the accounts that come with it. So let's bring the accounts in here from Brownie. And now if you within accounts, this is again a list of all the fake accounts, right? This is a list of all the fake accounts. From here, it doesn't matter to us which account we're using anyway, but we're gonna just use the first account. So the first account is kind of like how you work with Python in a list. We're just gonna say accounts 0. So we can just go ahead and say this is the first account, user account or admin account, doesn't matter. Just gonna say admin, and just gonna take the first item in the list. So we said whoever wallet that is, the first one, we're just gonna take that and we're just gonna say that's the admin. Okay. You're gonna pass in the dictionary. In here, you need a from and you from admin. So what this is doing is saying that, hey, deploy simple storage from where? From the admin. Where's the admin coming from? Well, that's accounts, the first items in accounts. Accounts, this is gonna be a list. Okay, a list. And so you're deploying from that. And just for good measure, we might as well just print that out. Just print. Let's save this to a variable. We call it SS, and so let's print SS. Well, that's it. So if you're getting some of this like Brownie could not be resolved, maybe you want to change your path and edit your Python path so that it knows where to find it. I'm not going to worry about that on the camera right now, but you can do that if you want to. So I'm just going to save that right now real quick, and then it says it's complaining. Okay, that's fine. Just ignore that for now. And from here, again, what we're gonna do is to use Brownie again. So just say Brownie deploy, not deploy but run. Run what? This is scripts. Deploy.py is under scripts. So let's do scripts / deploy.py. Now Brownie run scripts / deploy.py is gonna run this code. It's gonna first look for the main function and it's gonna run everything in the main function. So you want to put things in the main function. So let's go ahead and do that. Done. It says what? It says simple storage is deployed here, and then our print returns this. So with this print statement, it returns this. Now let's go back to our Ganache right now. Let me hop onto my screen. And in my Ganache, if we take a look at the blocks, you should see that now there is something in here. And you can see how much gas is used. We haven't really talked about all of these concepts yet, but we will in future videos. This is really a get started guide, just to get you started on trying to install the right tools, getting familiar with the ecosystem, how does different tools come and interact with each other. This is really the point of that. We haven't gone into the concept of like what is gas, what is mining and stuff. For now, you should see that if you click on blocks, you should see that there is the contract address, and if you compare the contract address, this is F9B55, and here again the created contract address is exactly the same, F9B55. And remember we said from the admin. Well, that's the admin. So what is the address of this admin? Well, here DEF354. If you go into accounts, you can see DEF354. That's the first item. Now the reason it's 100 still is because it's not really the gas to deploy this is so little that it's actually some small decimal point. So the actual answer is actually probably like 99.99999 and then some small values in there. So it rounds it up to 2 decimal point and you see 100. But it actually, the balance is no longer 100 that I'm telling you. So it's actually going to be, you're going to cost some amount of gas, a small amount of gas, just to be able to deploy this contract, and that's the first address. So we take the first account, and if you look at transactions, you can see that that this is the sender address. So this is what this is doing. It's saying that, okay, take the first guy gets to deploy this contract. Now the first guy itself, this is the address of that guy, which is from here. Okay, so far so good, right? So far you just deployed the smart contract, you have that running. If you go into the logs, you can see what actually is happening, and you will see exactly the same thing here, transactions, contract received. Now transaction is every time you try and change or modify something on the blockchain, modify the state or something, or create a contract or modify a contract or send a transaction, make a payment, whatever you're doing that alter the state of the blockchain, that's a transaction. In this case here, you're creating a contract. So it gave you contract creation, that's a transaction. And this transaction also, there's a way to verify that this actually indeed happened, and that's the hash 1 ECC. If you compare that to what you see here, that's the same here. Transaction sent 1 ECC. All right, pretty cool. So well done. You managed to just create spin up a local blockchain. You deploy that from Brownie, and you communicate with a local Ganache blockchain. Now let's try and do something a little bit cooler. All right. I want to maybe close this Ganache just to keep it there. You can keep it somewhere, just keep it there. But I want to show you as well that Brownie packs a lot of other things you can do with it. So to illustrate the idea, let me go back to simple storage, and let me just explain a little bit. What happens if I change or modify my contract? What do I do? Now, when you modify anything in the Solidity code, your contract itself, you need to recompile. Okay, so you need to do a Brownie compile again. Just to show you that, let's go ahead and make a few changes in here. So I want to maybe go ahead and I want to say that when the contract initialized, when it first created, I want to set this stored data to some sort of default value. Okay, so when this storage is first created, when this contract is first created on the blockchain, I want stored data to already take on some default value, some initial value. So to do that, we can use the constructor function. So if you're actually done programming in any kind of like object-oriented kind of languages, this is all probably going to sound very familiar to you. You probably do the same thing in JavaScript, in ES6, and even in Python when you work with creating classes and stuff. Very similar stuff. So here we're creating constructor, which says that every time your contract is deployed, the first time it's deployed, go ahead and do something. What do we want to do? Well, I want to maybe just set a value here. I'm going to set, and I'm just going to set 3. It's up to you what you want to do here, but I'm just going to say every time the contract fires up, when it's first deployed, I want to set stored data to a default value of 3, and set basically cost here. And that's it. So now that I made some changes to simple storage, can you guess what's my next step? What do I do? Do I do Brownie run scripts deploy? Do I do that, or do I do a Brownie compile first? Well, I need to do a Brownie compile first. If that's your answer, well done. So let's go ahead, say Brownie compile. Project has been compiled, build artifact saved, great. Now we have that in contracts, and we're ready to go. Okay. But before we go any further, I want to maybe just show you another way to just sort of play around with this. Okay, and the way to do that is we can do this thing called the Brownie shell. Okay, go into shell. I think it's called console, not shell. If you work with Django and you see there's a Django shell, that's kind of the same thing here. So when we say Brownie console, let's run that in here. Okay, it's already attaching to the RPC client, and if we go ahead and say simple storage, so the cool thing about the shell is that it already imports all of this for you, so you don't have to do it from Brownie anymore. It's already in there, it's already imported for you. So you can say simple storage, and you can see that there's nothing in here, and you can say accounts, and you can see these are all the 10 different accounts in here. Okay, but since there's no simple storage, let's go ahead and deploy a simple storage. And so you can do the same thing that you see up here. You can say simple storage deploy, and again you need a from account. So whoops. So I'm gonna say from, and we need a account. But remember, accounts is a list of all the different accounts. We only want the first one. The first one is what? DEF354, right? You can take the last one if you want to. I don't see why not, but I'm just gonna keep to accounts. So again, accounts, list of 10. I just want the first one, so you should be able to do a square bracket, list subsetting 0, like that, and close the bracket. So, whoops, curly bracket, close bracket. So this is not different from what you did here, except I'm just gonna subset index the 0, the first item directly from here. If you're first time to Python, 0 is the first index from a list. Okay. So if you want a second item, you put a 1. It's up to you, but I'm gonna just skip to 0, and you deploy that. And again, you see that, okay, now transaction is sent, okay, simple storage contract is deployed, successful. Okay, cool. Now that we have that deployed, we can go ahead and actually take a look at this, right? If we do a get from here, so let's just go ahead and say, take our contract. So we're gonna say simple storage. If we now print simple storage again, let's just see what's happening. Now there is, again, now there's one contract now. Earlier was 0, now there is 1. So we want to take this. So let's say simple storage, take the first one, or you want to take the last one, that's fine as well. So you can say if there are multiple contracts, multiple instances of this contract, take the last one. Now in Python, to take the last one, we say -1. To take the first one, you say 0. So take -1, take the last one. And from here, if I show you that, that's simple contract, right? We can go ahead and say a get, do get. Now, is get gonna cost us money? Well, every time you interact with the blockchain, it's gonna cost you some gas fee, right? But good for you, because get is set to be a view function. Now, this is where we talk about view functions. View functions are ways for you to implement a method that says, hey, we're not gonna make any changes to the contract, to the state, or to alter any values or anything. View is just simply, let me just return a value. And view, because it makes guarantees that it's not going to change or alter anything like that, it actually is free. So there is no gas involved. So you can do a get without having to actually put in an account and say, okay, I need to it takes some gas fee, so this is my account, go ahead and charge me the gas fee and return something. So when you call a view function, it's good. It saves the end user some cost. So here we're saying that since we're returning stored data, we're not doing anything anyway. We're not modifying the value. We're not changing the value. We're not doing something like this. We're not doing. I mean, this is fine, but we're not modifying stored data in any way, right? And because of that, we can call it a view. And so we can just say .get, okay? And we do that, we get a value of 3, and we get a value of 3 because when it first initialize, it sets the value to 3. So that's it. This is how you get to very quickly iterate within the terminal itself using just Brownie console. And once you're familiar with it, get a hang of it, you can move back to trying to do things in Ganache. And Brownie is fantastic, right? Truffle is fantastic. It gave you this Ganache that allows you to fire up a personal Ethereum blockchain, give you some demo accounts that you can play with. This is all fantastic. So what the next steps for you is to take a look at the documentation, read up about the docs, click on it, go through, get yourself familiar with Ganache, do the same thing for Brownie, do the same thing for Ethereum. There's a smart contract, take a look at that. We just implemented this one, right? The start. I mean, we added some of stuff here, but really it's the same idea here. So take a look at that, try and get yourself quite familiar with how all of these different components interact with each other. If there's a lot of interest, we can come back and do a second part of this video, and we can continue on it. We can build a, maybe an insurance contract. We can build our own coins and deploy our own currencies and play with it a bit more. But for now, I think I'll leave you with it. I just want this to be a really quick get started guide. If you're just new to all of these tools, you're saying that, hey, I know a little bit of Python, but how do I get started with this? What are the tools to get started with this? This is where I want to leave you at. And I will put all my codes in here. If we continue this series, there are going to be a lot more code that we write and stuff. I'm going to just mostly stick to the documentation in here. So I'm going to just walk through documentation. If you go down here, there is a, implementing a coin contract. We can talk about that. We can talk about the syntax a little bit more. We can talk about blockchain and, how do you, create good smart contracts and stuff. But for now, I'm going to leave you with that. And all of this code, I'm going to put them onto I'm going to create a new public repository. So it's here. And if you want to follow along and you're saying that, hey, some of my code doesn't compile, I don't know, maybe I missed out a semicolon somewhere, you can have a point of reference. So I'm going to put that, for your convenience, going to put that all in on my GitHub, and you can find that. And I hope that you find them useful. And if you need help, just raise an issue, click into that and create an issue in here, and I will try to attend to you. There are a lot of very good, fantastic resources on learning this. And so if you want to join the community, there is also a Facebook group that you can join. I think it's called Web3 Dev. So I'm going to be there. Right, so I'm going to be there. If you need to ask me questions and stuff, you can also do that on Facebook. So that's it. Happy learning. Hope to see you soon. Thank you. Bye.